for quality. So for our sessions, for the past sessions, we've been working around the title Rethinking Software Development. And in it we have always looked at the SWE book. That's the software engineering body of knowledge. We have worked around it and we have been building based on the, in quotes, the right way. And today we'll be looking at software security, and we'll be looking at building it strong. So why quality? Why should we build it quality and security? So quality and security are not add-ons, they are systemic properties. And if I continue, I'll introduce myself. For those who don't know me, I know most of you know me. So my name is Oriel Planet. I'm the engineering manager at Developers Mania. And this is a bit of my bio, my profile. So I'm driven by a passion for innovation. I've spent over 5 years designing and delivering software solutions that create real world value. All right, so quality is not something that you add at the end of the project. I'll say it's a necessity to design from the first day. So many teams treat software quality assurance like a coat of paint. They build a house, you know, the way you build a house, you ignore all the flaws and you just assume if you paint a layer of paint, at the end it will make everything strong. But that's wrong. So software quality is not like the paint. It's like the concrete foundation. You know, like if your foundation is cracked, no matter the amount of paint you apply, it will not stop the house from collapsing. So in short, you cannot test quality into an application. It must be designed there from day one. So what is quality? So that's a question most of the engineers should be asking themselves. And the answer to that is that quality is simply the degree to which your software satisfies two distinct types of needs. So we have two types of needs listed here. We have the stated needs and we have the implied needs. So what is the stated needs? So these are the needs that are written down from the project requirements. This is what you expect. For example, when you create a button, you expect that the button works very well, right? So if your button is supposed maybe to save a transaction, the function of saving a transaction is the stated needs. Then you have another need, is the implied needs. So these are the, or these are what the user automatically expects without explicitly asking for. So some of the, okay, sorry about that. So some of the functions that for the button, which is implied, the needs implied for a button, can be maybe the button don't crash the server, maybe it doesn't leak my private information, and maybe it doesn't process a payment twice. So we've been working with Z2, and that's a critical, I'll call it a fintech application. So we don't expect that a button that we create maybe will be processing a payment twice. So those are the implied needs. So quality ensure that these needs are met, the stated and the implied needs. So if you see the graph here, it has the cost of fix on our left side, and on the lower side, our x-axis shows the production times. So this means that if you don't build your quality early, from the design phase there, you have the design, the coding, and the production. So if you don't build your quality early, you'll pay an exponential penalty later. So a famous quality pioneer by the name of Edward Deming proved that inspecting a finished product to find a mistake is always too late. That's like inspecting a Toyota car at the end of the production. If you inspect to check the quality, that will not fix the quality issue. So in software, that translates to brutal cost timeline. So that means that if you catch a bug at the design phase, it will save you a lot of hours to deal with it later on production or in coding stage. So if you catch maybe a bug there at the start, I'll say it will cut the cost later, which might be even 10 times or more to deal with it later. Okay, so we'll look at some of the cases that happened, which are these parts were neglected. So we have two major disasters that happened, and the first one is known as the Equifax, which happened in 2017. So Equifax was one of the largest credit bureaus in the world. That's in 2017. And it suffered a major catastrophic security breach that exposed the personal, highly sensitive data of over 147 million people, which includes the name, social security numbers, we have the birth dates, and we have the driver's license numbers. So that Equifax costed, that catastrophe costed a lot of people. When you leak such kind of personal data, of course, the attackers are going to, we are talking about many attacks and most probably fraud using your personal details. So the hack actually, it wasn't a very incredible, complex or a futuristic cyber attack. So the hackers got into, to a known vulnerability in one of the third-party tools. We call them open source tools, called the Apache struts. And the twist actually is that the vendor had actually released a security patch to fix the bug around 2 months before. So Equifax engineering team can say it delayed or didn't apply the update in time. So the real lesson here, so of course the root cause wasn't a bad code, it was a process failure. So the team lacked a clear internal system to notice, to track, and to update their third-party dependencies. So that patch actually costed them over $1.4 billion. And then we have another case here in Kenya. It happened in 2023. So a medium-sized Kenyan circle was hit with a ransomware attack. So I guess we all know what a ransomware is. This is where the attacker gains access to your system and hold hostage your information. So one of the circles in Kenya in 2023 was hit with that, and they completely encrypted their core banking database. So what was the impact of that? The impact of that was that members woke up to find that they could not access their savings, their digital loans, and all the processes had been stopped because the attackers were actually demanding a massive ransom payout in cryptocurrencies. And the twist is that the circle never paid. So the hackers didn't crack any code. They used a very simple phishing email they sent to one of the system administrators, who actually fell for it and entered the logins on a fake login page. So the real lesson here is that the admin account did not have a MFA, multi-factor authentication. The worst of all is that the single account had the domain administrator privileges. So meaning that anybody could have any unrestricted access to the system. So because of this, a single stolen password took down the business for 11 days. So you can imagine a whole circle being held hostage for 11 days. So the circle actually recovered because they had a backup, but it costed them a lot because this is a circle. They work with money, and I guess, as we all know, they require a lot of good reputation. So the same attackers actually went for several sister circles of the same, who never recovered fully. Then we move to the next thing to look at is the adversarial mindset. So what is this? So from this point, we'll shift our perspective from a feature builder. A feature builder is like us software engineers, or I'll call us constructive thinkers. So want to move from that now to a system test, or in other language we'll call them the attacker. So who are the constructive thinkers or the builders? Yeah, it is the guys who ask things like, how do I write code so that this feature works perfectly for a happy and a normal user? So that's a constructive think. But who is an adversarial think? That's the attacker actually. These are the people who ask the question that, what can I type into this input box to force the application to do something that the developer never intended? So I guess if your software never accounted for this other person, this other thinking, you'll be in trouble. All right, so we have the 8 questions that you should ask yourself every time you run a PR, a pull request. These are the 8 questions you should ask yourself and try to find answers before you merge it. So the first one is authentication. So you should ask yourself, who is allowed to maybe to call this URL endpoint? And is there a guard, checking the identity token? The second one is the authorization. So even if the user is logged in, can user A maybe manipulate the URL to spy on another user's B data? That's the authorization part. The third one is validation. Validation asks the question that, did we strictly verify the type, the length, and the shape of every incoming piece of text? You should always answer that, because in every field, I guess we all know that you need to specify the data type, you need to specify the length of the string you want to accept into your database. So that's the validation part. You have the regenerate inputs. So what happens if someone sends a completely empty value to your field, or maybe a negative number, or maybe in that text input somebody uploads a massive 50 MBs of data, simple text? What happens? Will your server crash? That's the degenerate inputs. So we have also the sensitive data, which begs for the question, are our background server logs accidentally displaying or saving raw user passwords, phone numbers, or secret API keys, in clear text? Are they very safe? That's the question you should ask yourself before you accept that pull request. We also have the rate limiting. The rate limiting is can a malicious script spam the login maybe or OTP endpoint maybe 100,000 times, 10,000 times per second, until the server runs out of memory and dies. That's the question you should be able to ask yourself. You also have the secrets. The secrets, is I'll call them the hard-coded passwords, database credential. Have they been left accidentally behind, in the code base? So these are the secret. We talk of .env, all the items that are inside the environment. Are they safe? The last one you should ask yourself is the test. So do you have an automated test that explicitly proves that a bad actor gets blocked with an error? So you have those, I should call them the cheeky people who, will try to change the route. So if they change the route, maybe will they get an error? That's the question you should ask yourself before accepting the PR. So the next we'll look at the ISO pillars and OWASP reality. So based on our SWE book reference, these are some of the, I'll call them the 5 pillars to help you build a balanced application. So we look just beyond code here, looked about beyond there, and these are the, I call them the 5 master traits you should master. So the first one is the functional suitability. So you ask yourself, does the app execute its basic promises correctly? So you have that functionality when you create maybe a function. Now you should ask yourself if it executes that specific one. The second one, we have the performance efficiency. Ask yourself, is the app fast and stable under heavy traffic? I mean, you should not expect maybe a dashboard to freeze and spin forever if maybe 100 users access it at the same time. We also have the reliability, which begs the question that can the system stay alive and gracefully recover when the external services crash? Have security. So security, it begs the question that are the assets secure and trackable? Here, the failure in this case will be maybe an authenticated attacker who finds maybe a hidden endpoint and drains the pool account. So, is your name secure? Is your application secure? And the last one is maintainability. So, in this pillar, you ask yourself, is the code tidy enough that maybe a new engineer can read it, understand it, and maybe update it safely? We should not expect that maybe changing text on the registration screen, maybe it accidentally breaks the payment gateway. That's the meaning of maintainability. So next we look at this OWASP top, they're always top 10, but I looked at the top 5. So OWASP is the Open Worldwide Application Security Project. This is an organization that maps most of the security mistakes globally. So the latest guidelines highlight most of the critical zones that every developer must understand. But let us look at these top 5 in the list. And the first one, you have the broken access control. This is ranked first, and this happens when you forget to check the permission at the door. So it's like maybe your application logic assumes a user won't look at a page and invoke a root. So is this safe? So if I log in as a certain user and I manipulate the URL, will I be able to access the other person's data? And that's the first risk there. That's the first threat. And the second one we have is the security misconfiguration. What is this? So this risk sits second in the OWASP list, and it's because modern software relies heavily on complex cloud environments and setup configurations. So we're talking about the .env and such kind of environments. So security misconfiguration can be something like passwords unchanged. We have the default passwords. Maybe like logging into an admin account, you always have the admin and admin as the password and the username, right? So if you leave that, that's an example of security misconfiguration. Somebody can get and gain the access easily. Another one is the leaving maybe the framework debug screens active in production. So of course we have worked with all these frameworks, or most of them, and we always have that debug screen when there is an error. It always displays on the browser, right? So if you leave that one, in an active production, guess what? You are giving the attacker the right space. He can actually understand your code base, some of the files, even he might even understand all your structures. The third one is the software supply chain failures. So this sits third in the list, and it's because modern apps are built using thousands of third-party open source packages. Talk of NPM, PIP, Maven. So an attacker can actually compromise that by changing a tiny bit of one of the packages inside there. And you might accidentally install it. So this is one of the highly rated threats to the software. The fourth one is the cryptographic failures, and this occurs when sensitive data is exposed because it was poorly protected. So example is using some of the broken hash functions. I know some of us are from the cybersecurity field, and when I talk about MD5 and SHA or SHA-1, you understand that. So these are some of the, I'll call them the weak hash functions, which are, can say they can be easily cracked. So these are some of the cryptographic failures. It sits right at the fourth position. The fifth one is the injection. This is usually very common. Talk about when your server takes untrusted user input in one of the input fields or a form in your website. So it might accidentally execute it as an SQL query or even a system command. So that part is the injection, and let's look at it more. So in the above code, do you see anything wrong? Of course, I wrote dangerous, so definitely something is wrong with this code. But anyway, so the danger in this is that it takes raw input and stick it in the database directly as a query string. There, when you return this .db.run, it takes the raw inputs from the user and it runs it as a database query string. So a malicious user can actually type some of the words. There is one famous one, which is, I think, 1 or 1 is equals to 1, something like that. If you put it in the input field, the database engine actually interprets it as a text query command. So it bypasses all these conditions, like select all from users, where you are trying to just access one user. And it leaks all the user accounts in the system. So this is very dangerous. So what is the right way to do it? So this is the remedy, as you can see. So this .db.user.find unique. So most of the frameworks isolate the variable safely. So the remedy for this is we use parameterized queries, which is packaged with most of the modern web frameworks or the ORMs. They safely isolate the user text variables from core database compilation logic. So when somebody inputs a database query into the input fields, it will be treated as strictly a string. So based on all that now, what is our next step? What should we do? So we have looked at the global disasters, the OWASP top 5, the top 10 critical OWASP. None of it matters if we don't change how we code. So I want to give you two simple rules which you can take back today. And the first one is we should stop doing security checks room by room. So writing manual and messy, maybe if-else statements for every single input field, it's like letting people into a secure building, but the door is not protected. So it's like you allow people into a secure building and then you start chasing them down room by room, you know. So at some point you will forget one of the doors. So instead you should lock the main door or the main gate by using some of the validation pipelines. So we have like the Next.js validation pipes, we have the automated API schemas, and we have many more based on the frameworks we use. So when a request contains a malicious text or a bad data type, the pipeline, like the Next.js validation pipes, they reject it instantly. They ensure that bad data never sets foot inside your core business logic. The second one, we must make fail closed, like our standard absolute team standard. So normally code breaks, we don't argue with that. Code breaks, payment APIs go down. But we can't split the raw technical trace for any normal user. So like the example I gave you, the errors, the debug errors, if you display to in production, an attacker might find it, you know, as one of the perfect maps into your system. So they might get all the backend folders, your database structure, and even your library versions you're using. So another thing is that our error handling must shield our systems. If an exception occurs, these are the try catch. If that exception occurs, we should show a user a polite and a generic message, something like something went wrong on our end, maybe please try again later. That's the thing you should be displaying to all the users. But silently, you should save all the full, the detailed, and all the error logs in the secure backend file where your engineering team can work on it and debug. And to wrap it all up, summary of it all is that security isn't a feature you add right at the end or before you ship, but it's a standard you maintain every single day. So if you're not actually thinking about breaking your own code while you're writing it, I promise you someone else will. So let's build it strong, and thank you for your time. I'm very honored to be your speaker today, and I'll open doors for any questions.